Hi everybody. A very good morning to one and all present here. This is Bharat, Assistant Professor, Department of Electrical and Electronics Engineering, SNS College of Technology, Coimbatore. So today in our lecture series, we are going to see about a case study. So as a part of the subject, we have been dealing with several cases in several factors of different units. So today we are going to see a case similar to our subject, what we have been seeing in power systems. And today what we are going to discuss is about a real-time implementation of some. So this is a source file from NIST, from the National Board. So that is the generation, transmission, distribution, and the customer. Here also comes the service provider, operations, and the market. So always there is a complete interlinking. So the customer can have a link between the generation and the markets and the service provider. So now it becomes a bi-directional flow. Even at the customer's end, you can see a solar plant or a wind where you can generate power and you can give it back to the power market. Okay, a service provider and an operator. Okay, so this is the main or the important part or the important concept of a smart grid when comparing to the conventional grid. That is, the main point we can take it up is the only one line power flow is possible in the case of a conventional grid, that is from the generation to the consumer end. But in the case of a smart grid, there is possibility of bidirectional power flow. That is a very important concept behind your smart grid. So now coming to our advanced metering infrastructure. So what is this advanced metering? So instead of having a traditional meters, we are going into a new type of meters, which is called as the smart meters. So what is smart? So what we have something smart in this. So you could see the different applications or the features that can be performed by this smart meters are listed over here. I'll just go by one ESI. Okay, energy service interface. That is HA network interface components with NIC. NIC network interface component to exchange data to outside world. LOV detector, loss of voltage detector to send supply failure. TOU register, time of usage register, that is billing will be based on time of use of energy. So input output unit, connect or disconnect of circuit breaker, transformer, temperature information. Power quality, measures and stores the power quality data. Load profiles, measures and stores various load profiles such as the maximum demand, remote support, remote firmware upgrade, and the configuration. Security, detects and alerts meter tampered or tampering and power theft. So all these things are performed by a single meter. So what we saw as the challenge in the normal grid, the four different challenges in the first slide, is now taken care by this smart meter. So the smart meter network interface card has this following application. That is a distribution application apps like meter data management system, demand response management system, distribution management system, outage management system, and customer information system. So this is even done with a very simple concept of interfacing the network with the meters. Okay, so how they are interconnected, how the communication takes place. There's nothing but the telecommunication. We use a simple SIM, what we use in the mobile phones in the meters. Okay, so the smart meter starts communicating with the different persons like the user, the customer, the utility, the operator, and everybody. It can easily communicate without any human interface. So here we see the block diagram for this telecommunication media, smart meter, GPRS, modem, and the distribution operation applications. Yes. Now coming into all these features, what we have discussed now, we are moving into the smart grid pilot power project taken by the government of Puducherry, the Electricity Department of Puducherry, and the National Power Grid Corporation. Okay, so they have completely implemented the smart grids, that is the advanced meters, in even each small household till the biggest industries or the government or the commercial buildings, wherever the smart meters have been implemented. So here you could see some images which was taken from the NSTC website for the purpose of education purpose. So we can see in each house they have implemented a smart meter. So you can see at the end, what is the infrastructure, and at the office side and at the operation side, smart grid control center, PEDs, available at different parts of the Puducherry project. So what is the screenshots tell about? So what are the attributes implemented is the advanced metering infrastructures. We can perform the peak load management, including demand side management and demand response, outage management system, renewable energy integration with net metering, power quality management, microgrid, energy storage, and electric vehicle with solar charging station, street light automation. So all these things can be managed with the help of these simple smart meters already implemented. So what is the use of this smart meters? So you can see how this takes place in the Puducherry project. Okay, so this you can see in a specific area called Marapallam substation. From there, we are going to take 2 lines, which has several feeders for towns and different areas. Okay, we have the DCUs, DSUs, advanced metering infrastructure, that is smart meters for each houses, controlled by SCADA, by collaborators, OMS, GIS mapping, PLM, MDMS, and head-end. So Billions, the Puducherry Control Center also has a link over it to data collection unit, transfer monitoring unit, and all those units have interconnection between all the places. So the communication becomes easily from the even at the load side. So this is the location of installation of these smart meters in the Puducherry. So you can see the image taken from the Google. So where all these smart meters are implemented, all those green colors shows you the smart meters. Blue color represents the APFC, and those boxes, green boxes represents the DCUs, and yellow color lines represent the DPs. So this is the outage management system, one of the important application of the smart meter. So you will receive a message. So Marapallam, so the outage happens. So what time, what period, and that has been received to the customer. So this is a screenshot of the customer who had received the message. Okay. Yes, so we saw about the power theft. This is the mail received to the utility, to the as a power source from the power grid, where there is a tampering happening in some part of the area. So they have given the meter, date, time, and area of Puducherry where it has been happening, and all those things, so that the utility can take these action immediately. So based on all these things, what are all the outcomes? What are all the applications of this advanced metering infrastructure? Is the bulk meter reading, home energy management system, outage notification, connect or disconnect the system, asset management, remote programming of smart meters. So I think you have come across a brief case study about the implementation of a direct implementation of a real-time project of Puducherry pilot project. Let's see in the next class. Thank you.